Listen. First, consider this problem. Differentiate. We need to identify local maxima or local minima points for the function. So differentiation I have done, make it equal to 0. I got x value 1 by 2. Then take the number line, mark 1 by 2. Then right side f dash of 1 by 2 plus left side f dash of 1 by 2 minus. So consider f dash of 1 by 2 plus, okay, f dash of 1 by 2 plus. What about the sign? 1 by 2 plus means more than 0.5. More than 0.5, if you substitute here, it will be negative sign. F dash of 1 by 2 minus, what about this? 1 by 2 minus means less than 1 by 2 means less than 0.5. So if you substitute that, it will be a positive sign. You can check and verify. Okay, so here it is negative, it is positive. Means first of all, it should increase because f dash is positive. After that, differentiation will be 0. After that, again it should fall. Okay, fall means it should decrease. Okay, so graph will be like this. So at 1 by 2 you can observe, what you can observe, local maxima. So x equal to 1 by 2 is local maxima. That's it. Next problem. Given function f of x is x plus 2 cos x in the interval 0 to pi closed, open 0 to closed pi. Point of local maxima, local minima we need to discuss. First, what we have to do, differentiate 1 minus 2 sin x. So let us do one thing, take 2 common, it will be 1 by 2 minus sin x. So make it 0, f dash of x equals to 0, then sin x will be 1 by 2. In this interval, what are the angles for x to make this 1 by 2? So to make sin x 1 by 2, x will be pi by 6, 5 pi by 6, okay, 30 degrees, 150 degrees, okay. Now consider a number line, arrange pi by 6 and 5 pi by 6 and moreover pi also and 0 also, because 0 and pi are the boundaries of the interval. Okay, draw the graph of sin x 0 to pi, 0 to pi. This is 1. Draw the graph of y is equal to 1 by 2, y is equal to 1 by 2. This is the graph of y is equal to 1 by 2. This is y is equal to sin x. Both will be equal at pi by 6. Pi minus pi by 6 means 5 pi by 6. Okay. So listen carefully. We need to discuss the sign of this f dash of x between here and between here and between here. It is enough to find the sign in these three intervals. So less than pi by 6 but more than 0. Less than pi by 6 but more than 0. 1 by 2 is more than sin x. Clearly you can observe the black line will be more than the red curve. Okay, between 0 and pi by 6. So 1 by t is more, then we will get positive sign. Why? Because here 1 by 2 is more than sin x. big minus small will be positive. F dash sign, this is f dash of x sign, okay, positive. What about here between pi by 6 and 5 pi by 6? Here curve is more, means sin x is more here. Between pi by 6 and 5 pi by 6, what will be big? Here sin x curve is big, okay, so then small minus big, you'll get negative sign here. Then again in this interval you'll get again positive, okay. So this is the sign of f dash of x. So listen carefully, what about the curve between 0 to pi by 6? It should increase, okay. After that it should decrease, okay. It should decrease, after that increase. Pi closed means you need to take a closed circle, here open circle, okay. This is the imagination of the graph, okay. So listen carefully, at pi by 6 you can observe, at x is equals to pi by 6 you can observe local maxima, local maxima, okay. And moreover at pi also you can observe local maxima, at pi also you can observe local maxima, okay. Now at x equals to 5 pi by 6, local minima, okay. I think it is very clear for you. Let us discuss about nth derivative test. Nth derivative test. Let f dash of alpha equal to 0. We need to find whether local maxima or local minima. Local maxima or local minima at x equal to alpha, or none, or none, or none of these, or none of these exist, for which find f double dash of alpha, f triple dash of alpha, f fourth derivative means function fourth derivative at alpha, so on up to where? Till non-zero value is obtained. Till non-zero value is obtained. Let us say it is obtained for nth derivative, means nth derivative at alpha is non-zero. Case 1, if n is odd, x equal to alpha. If n is odd, then we can say x is equal to alpha is neither maxima nor minima, neither point of local maxima nor point of local minima. Case 2, if n is even, x equal to alpha is local maxima or local minima according to the sign of nth derivative of alpha. If it is negative, local maxima will exist. If it is positive, local minima will exist. Whenever it is positive, local minima will exist. Whenever it is negative, local maxima will exist. Okay. Let us solve this problem using this method. First, f dash of x I am going to identify. F dash of x will be 3x square minus 12x plus 12. Make it 0. If you make this 0, you'll get x equals to 2. Why? Because it is a perfect square after taking 3 common. Okay. Then so f dash of 2 becomes 0. Now let us identify f double dash. F double dash of x. F double dash of x is clearly 6x. Differentiate this, minus 12. Listen, at x is equal to 2, it becomes 0 again. So that's why triple dash we want. Non-zero derivative we want. Okay, triple dash means 6. This is non-zero. This is non-zero. Non-zero. But this is an odd number of derivative. So whenever odd number of derivative, if you get non-zero, neither local maxima nor local minima. Neither local maxima nor local minima at x equal to 2. That's it. Consider the problem f of x equals to x power 4 minus 16x square plus 13. Analyze local maxima, local minima points. Let us solve this problem. First find f dash of x. F dash of x will be 4x cube minus 32x. Let us take 4x common. It will be x square minus 8. Make this equal to 0. Okay. X equal to 0 or x equal to plus or minus 2 root 2. Okay. Now we have to check x is equal to 0. X is equals to 2 root 2. X is equal to minus 2 root 2. Okay. F double dash. F double dash of x we need to identify. It will be 12x square minus 32. 12x square minus 32. F dash of 0 means f double dash of 0 we need to identify. Whenever this is 0, we have to go forward for f triple dash. If this is non-zero, then the problem will be ended at here. Okay. So 0 if you substitute, it will be negative 32. Means f double dash of 0 will be negative. Whenever f double dash is negative, f double dash is non-zero and f double dash is negative, what will be the answer? Local maxima. X is equal to 0 is point of local maxima. F double dash of 2 root 2 we need to identify, and moreover f double dash of negative 2 root 2 also we need to identify. So anyhow both will give the same result. Means what? Positive result. Whenever eventh derivative is non-zero and it is positive, x is equal to plus or minus 2 root 2 points of local minima. Yes or no? Next problem. F of x equals to x power 4 minus 4x cube. Analyze local maxima, local minima. Let us solve this problem. F dash of x, it is 4x cube minus 12x square. make f dash of x 0, then what you'll get? X is equal to 0, x is equals to 3. Will you get 3? Yes, wait a minute. So we can write this as 4x square. If you take common, it will be x minus 3s. Yes, very good. X minus 3 we will get. Okay. So, yes, correct. X minus 3 we will get. So, x is equal to 0 or 3. Now, listen carefully. If you get x is equal to 0 or 3, first let us check at x is equal to 0. After that, at x is equal to 3, we need to check. At x is equal to 3, we are going to check. First, find double dash. F double dash. It will be 12x square minus 24x. At x is equal to 0, it is giving 0. Okay. Continue. Finding triple dash. It will be 24x minus 24. At 0, it is giving non-zero value. F triple dash of 0, it is negative 24. Because it is odd and giving non-zero, neither maxima nor minima at x is equals to 0. F double dash of 3 we are going to check. F double dash of 3 means 12 into 9 minus 24 into 3. Okay. What will be local minima? Local minima at x is equal to 3. That's it.